Hello, this is Satbir. The topic of our discussion in this video tutorial is a linear function. What is a linear function? Linear function can be written as f of x is equal to mx plus b, where m and b, they both are constant. And x, which is the input variable or independent variable. So the input is x, and the degree of the input must be 1. The degree of the input variable, the degree of x must be linear or 1, because this is why it is a linear, because of it is a degree. And also the constant m and b both are constant. Let me give you the few example of linear function. So f of x is equal to 2x plus 3. This is a linear function. You can say h of x is equal to negative 1x plus 4 is a linear function. And you can also write y as a 2x minus 4. Instead of writing f of x, we can also write y, where y is the independent variable. And this is also a linear function. Here, m is a very important constant, which is multiplied to our input x. So the m is called the slope of the linear function. Slope of the linear function or our linear function. Linear function can be written in 3 ways, and these are the 3 ways we will discuss next. The first way we can write the linear function is a slope intercept form, which is basically mx plus b. If I have to give you an example, it will be 2x plus 3. That's the same example, x plus 3. Here, m is the slope, as we discussed in the previous slide. And this constant y, this is now called a y-intercept. Y-intercept. The another form is a point intercept form. If you have given a function y minus y0 m time x minus x0, if you write a function in this form, this will called a point intercept form. An example will be y minus 1 is equal to 3 times x minus 2. This is in one example. In this case, this constant will be slope. And in this case, we don't have a y-intercept, but we have a point. And the point where the function, the linear function is passing is a 1, 2, this point. There is also called a journal form, where x and y, they both are on one side, and there is a constant on the other side. See, this is called a journal form. For example, 2x plus 3y is equal to 3. In this case, we can't really directly compute the slope of the function, but after some simplification, you will be able to find the slope, and the slope in this case is a minus a over b. The way to find the slope is basically converting the journal form into a slope intercept form, and then you can find the slope from there. So next is how to graph the linear function. The one thing to notice, the graph of a linear function is always going to be a straight line. So this information will be really helpful. But for example, we are given a function f of x is equal to 2x plus 3. And as you can see, this function is written in term of y-intercept form. So 2x plus 3. So when the function is given in the y-intercept form, this constant is the slope of the function. And this constant is the y-intercept. Y-intercept. So now to plot the graph of this function, all we need to do is we need to first plot the y-intercept. So this is if 1 unit, this is a 2 unit, this is a 3 unit. Let's suppose this is a 3. So I will mark this one. And then I have a slope. So slope of the function is always read as a rise over run. But here the slope is a 2, so I will read it as a 2 over 1 as a fraction. So now I'm going to use a different color to explain this one. So what that means is a rise. So you 2 unit rise. So this is a 1 and 2 unit rise. And then you run 1 unit in this direction or somewhere here. So that's where basically you circle the second point. Now we're going to find a line, or we're going to draw a line passes through these 2 points. And that will be the graph of our function f of x is equal to 2x plus 3. Let me take one more example. In that example, we will graph the function. If the function is given in term of a point intercept form. So for example, let's suppose you have a function y minus 1, and then you have 2 over 3 x minus 1. So this is the equation of the function in term of a point intercept form. This is also a famous form of this function. So if you want to plot a function of this, like again, first is we need to plot the point, which is this point. So the point is, I'm going to write it here. The point is 1, comma 1. So if I go 1 unit here, 1 unit here, so this is the point that is 1, comma 1. And then the slope here is 2/3. So it means I have to rise 2 units. So I rise, this is a 1, this is a 2, and then I run 3 units, 1, 2, 3, somewhere here. So 1, 2, 3. So that will be the second point, point of interest. And then I will draw a line which passes through these 2 points. So this will be the graph of my function y minus 1, 2/3 x minus 1. Now, if you have a function which is written in the journal form, so what I suggest is to convert that function either into a point intercept form or to a slope intercept form. And how you can do is basically you have to solve for y in term of x. So in this case, if I add -2 on both sides, I will get minus 2x plus 1 on the other side, and then I will divide by 4. So I'm going to get 1/2 x plus 1/4. So this is now a slope intercept form, and I can use the first method to plot that function. Next, I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. Next, I have an exercise which has some real world application. So first, let's read the word problem. If you buy a cactus, which is a 5 feet height, and it grow at a rate 0.2 inches each year, express it is height in inches as a function of its time in year since the purchases. So as you know that the height of any animal grow linearly, so we can find the linear function which will express the height of the cactus in t, or the number of years. So the solution, first notice our function are gonna be this form h of t, where h of t is the height of the cactus. The m is the slope, or in other word, it is the rate of change at which the height is changing. T is the independent variable times, which is going to be in years. And then there is going to be a constant b, where basically the height of the catechus start. So as you can see here, the M is given as a 0.2 because this much height, this many inch, the catechus, the height of the catechus increased every year. And the B is gonna be the starting height of the catechus, which is given as a 5 feet. So therefore, the function of the catechus height is going to be h of t is equal to 0.2 t plus 5. This will be the height of the catechus. And then very interesting problem, you can even predict what will be the height of the catechus after 10 years by just inserting 10 into your function. So that will be 2.5 times 10 plus 5 because 5 was the original height and that much will be the increase in the height of the catechus. So therefore, this will be is equal to 10 multiplied by 0.2 will be 2 plus 5. So your catechus will be 7 feet in height after 10 years. This is also the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.